Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
And traveled quite a distance here from the University of Bern in Switzerland. He's a fourth-year master's student at the IM Institute Informatics and Applied Mathematics team at University of Bern, Switzerland. The talk he'll be giving this morning is on traits in C#.
Okay, thank you. So, I'm going to present you traits in C#. They have been developed in my institute. The main researchers are Oskar Nierstadt and Stefan Dukas. Unfortunately, they couldn't attend this workshop. So, my talk will be like this. So that's a roadmap. So that's the first part in which I will explain shortly what traits are and why we need them. And then I will come to traits in C#. Okay. So why traits? So the concepts about traits are code duplication, fragile compositions, and about sharing code. So there are already a lot of approaches to share code. So reuse mechanisms, we can say. So for example, single inheritance. So that's just the mostly used one. We all know that this is pretty limited. So if you want to share code, then we have to push the code up in the hierarchy, and that's not so nice from the concept of object orientation. Then we also have multiple inheritance, but so that's not very better. It's just too complex to realize, although the concept is actually pretty nice. It's not much better with mixins, so the concept of mixins would be actually good, but mixins are pretty complex as well. So when you use a lot of mixins to share code, then our compositions getting fragile, and we notice these so-called ripple effects, and they're pretty nasty to solve. Okay, so the solution to that is pretty simple. So just traits. They're pretty effective and efficient to come around with this stuff. So what's a trait? So we describe a trait as a first-class composed time group of pure methods. We could also say it's just a primitive unit of code reuse. So a trait is actually nothing more than just a unit that holds some behavior. We can describe that like this. So we can show this like this. We have a trait. It does have some behavior, so that's what the trait provides. That is what the trait implements. And we have another side. That's what the trait requires. So these are the methods that the trait depends on. A trait is completely stateless, so it does not define any state. So that means no instance variables, no constants, nothing like that. And it does never access state directly. So when we want to access state in a trait, then we're using the requirements here. So this would be actually the accessor methods, like you see it here. So that's small talk syntax on that side. So a trait is just pure behavior, nothing more. Now, how can we compose traits and classes? Traits do not introduce a completely new model, so they actually only complement single inheritance, which is pretty simple. A nice thing in the trait composition is that the order is completely irrelevant, so that's a big difference to mixins. So when we use mixins, then we have to keep track about the order of the mixins, and that gets nasty. So we don't have that with traits, and that makes a lot of things easier. Beside that, another nice feature is that the composite entity, so that's the class, is of the full control of the composition. So that's not the case with mixins, and that's also pretty nice with traits. So we can visualize this like that. So a class is just what the superclass defines, some state, the traits that we plug in, and a bit of glue code. So glue code is the declaration, actually, how we can use the traits, how we define them, and what is behind the system. So that's the background, so we don't really care about the glue code. So what more about composition? So the composition is really simple. Actually, there's not really much to say about. All the rules that apply for the composition are actually consequences by the flattening property. I will just come to that in a moment. So, for example, the rules are class methods take precedence over trait methods. That means when a class is using a trait that defines the same method that are already in the class, then they're not used. So that's just normal. The same applies for overriding, so there's no change in overriding and the hiding mechanism. So if a class uses a trait, then the trait methods do override the methods in the superclass of the class that is using the trait. So that's just pretty normal. And a very nice feature in the trait composition is, so that's very important, that self, this, super base, or however we call them all in different languages, have exactly the same meaning than before. So that's also a big difference to mixins, for example, so there's a slightly change. So the flattening property. So what is the flattening property? The flattening property says that the structured view or the concept of traits is completely equivalent to the flat view of traits. So we can say if we use a trait that implements some methods, then this is exactly the same if the class would implement the methods by itself. So that's it, actually. So that makes a lot of things easier and has a pretty big impact to the understanding of traits and how traits are working. So, for example, it gets completely clear why these super base have the same meaning than before, because we actually have nothing else than no other composition model than we had before. So this is just, single inheritance. So there's no change. Overriding, hiding, no change. So it's the same. But with the difference that we can share these methods here by putting them into a trait, and like this we can share them among multiple classes, multiple hierarchies. So unfortunately there can be some conflicts when we using traits in classes. However, they're pretty simple. There's actually only one conflict that can appear. So that's when we are using one class that uses two traits defining exactly the same method signature. So we actually don't know which method we would like to have. So to come around with that, we have two operations. One is the alias, and the other one is the exclusion operation. So in that example, we can simply fix that conflict applying an aliasing. So we just say in that class, so as it controls everything, we make an alias on that operation and on that one, and we implement the equals operator in the class itself, because there's no conflict anymore, because the class methods take precedence over the trait methods, and so we can fix that conflict like that. So we can go to the code. That would look like this. So this is already a little example that shows a little bit of C#, or how it could look like in C#. So we have our trait declaration, how we can use them, the alias, how we define them, and we implement just the method in the class. And we have no conflict, so that's pretty simple here. We could also solve this conflict differently. So for example, if T-circle does already implement the behavior we would like to have for the equals operation, we just take that and we exclude the one that comes from T-color, and we have no conflict either. So when you go to the code, then it's even simpler, so we just have the exclusion on the equals operator. Okay, that was a short introduction about traits. So they're widely available in dynamically typed object-oriented languages. They were mainly developed in Smalltalk and recently ported to Slate, and they will be also integrated in Perl 6 under the codename role. Our experiences with traits are that they are really simple and actually very expressive and efficient for sharing code, avoid code duplication. Okay, now the question is what happens when you want to port them to statically typed object-oriented languages. So there are ports for Java in Scala and in Mini Java. Well, I don't know if you know Scala. There's a little problem with Scala. It doesn't provide overriding and hiding. So the use of traits and sharing code is pretty limited. So that's just nice for demoing, but you can't really implement big applications in that language. And the same for Mini Java, so that's just Java with everything removed. That makes Java to Java. So that's just for demoing. So now traits in C#. So you see here a list of things you can do with traits in C#. Of course, that's far too much to talk about in half an hour. I will just pick 2 topics. So I'm going to talk about the syntax and declaration, and a little bit about typing traits and typing problems that we get in typed languages. There are a lot of other things, as you see in this list, and the list is not even complete, so it continues. Okay, syntax. So when you're using traits in a statically typed languages, we need a type declaration. So that means that alias operation, exclusion operation, and the requirements need to be typed. So the solution to that is pretty straightforward and simple. So we use argument types for alias and exclusion, and the same for requirements. And for requirements, you can also use return types. So just to show you an example. So on the left side, you see how it is implemented in quick small talk. We have our trait declaration here. We see it in C#. Here you see how we type the declaration. So we just put the types into the list between braces. So that's pretty simple. So if resize would use another parameter, then we would just put comma and the next type. Okay. Then the trait, we probably just put them into a single file. So that's pretty simple. And we have here our requirement declaration, so return type and the signature of the method. So that's pretty easy as well. So with the requirements, we don't really need to use the return type. That's actually optional. But we can constrain the interface towards the class. And that prevents a lot of compile time errors. But it's not really necessary. In fact, in typed languages, we don't really need a requirement here. So we can actually resolve the requirement by just looking through the code in the trait and see what is missing. Okay. So typing traits. We have here a little triangle problem. So in one edge, we have traits, so what they provide. So they are for code reuse and sharing code. We have a goal when we're trying to introduce traits in statically typed languages so that they should still be simple and flexible to use. And we have a lot of types, so we have to address argument types, return types, temporary types, and so on. So what's the problem when typing traits? So the question we have to ask are, when we implement a trait, what argument types do we use for the methods in the trait? Or what return types do we use in the methods to define the methods? Because we would like to share the code among different classes, among different hierarchies, so it should be flexible. And for example, what or how can we return the type of the class that is using a trait? And of course, temporary types, have to address them as well. And always keep in mind this should be simple and flexible. So to show you an example, what's the problem? So we have here a class, my collection, that uses a trait tsequenceable. The trait tsequenceable provides here 2 methods. So we have reverse and concat. And you see here with the question marks the problems we have. So we have to decide, we have to put something in here. So just a type. So the problem is, what types do we use here to make that trait shareable and flexible to share? Okay. So there are many possibilities and solutions worked out for that problems. So a straightforward solution is just to use simple or concrete types or just interfaces. However, this is pretty limited. So when we use interfaces here, that's okay. Even here it's okay, and here. But yeah, that's a problem. So we have to instantiate something concrete here, and that's not very nice, because we would like to share that code. And when you put something concrete in there, then the flexibility is pretty limited, actually. So we actually have no flexibility. Well, however, when we use already interface types here or concrete types, we can share a lot of code, but not in all cases. So there might be some situations in which we can't use the trait, and we have to duplicate the code again. Okay, there are a lot of other approaches, so we'll quickly talk about the explicit type parameter, and then about implicit types and generics. Okay. So when you're using explicit type parameters, that looks a bit template-like, so you will immediately realize that. So it's the same example. We have the trait. We give a type parameter, so actually we can put everything we want in here, so just any type we would like to. And we define the trait, a bit template-like, but however, all the trait properties apply to that structure. So we define a type parameter, and we can flexibly put that type parameter where it is necessary or useful to use. So this approach is pretty simple and very extendable and flexible. As I said, it's a bit template-like. However, the disadvantage in this approach is, when we go back, that you have to keep track of where you're using these types here, so you can use them anywhere. You don't need to use A, for example, in here. You can just use it here for return types. There are many possibilities where you can use this type parameter, and that's actually very bad, because when you're implementing a lot of traits, the developer has to keep track of all these types and where they're used, how they're used, and that's actually not such a nice solution. Okay, another possibility could be implicit types. So we define the same thing again, give a type parameter. However, now here we're using generics, so it's not a template-like trait anymore, but a generic trait. We're reusing the generic type of the class that is using that trait, so we can address these types in this trait here. That makes it very flexible. It's actually the most flexible solution we have. And for return types or addressing types, we just put a little placeholder that is actually the type of the trait. Well, it's not really a trait, it's more a placeholder. In that case, t-sequenceable. And when the trait is used by the class somewhere in the system, then t-sequenceable for the here gets replaced by that type here. Okay. So that approach is pretty simple as well. However, it has a limitation as well, because the return type we're using here will always be the one of the class that is using that trait, and this might not always be useful in any cases. So, as before in the other approach, that is actually a fact that we had to realize. So that we can't just make a solution that applies to every situation. So that's pretty difficult to find out, and we're doing a lot of research to find another solution that apply to most situations that programmers probably need or have to need. Okay, so now back to the overview. So we just scratched the surface of two little topics. There are lots more to talk about. now come to the prototype implementation. So in that project I developed a little prototype that is based on a preprocessor directly using the flattening property. It doesn't need to be like that. So what I'm doing is I'm just applying what the flattening property says. I just compile away the traits, put them into the class, and then we can just compile these classes using existing compilers. So that's a very simple solution. The prototype provides a simple type, so we can use interfaces and all that stuff in the trait, so that's the simplest solution we can have. And the prototype does also provide generics in the traits. Beside that, we have a very simple syntax, so that's what I showed you before. So it's very minimal, with not much of overhead in declaring things. So, everything is done with a generic parser. So this parser is actually pretty nice. It can also parse other CLAC languages. So with this prototype, it can also handle Java and Object-C, C, C++, and all these languages. It's based on a little code DOM framework, and the flattening logic that is doing all that fancy stuff is independent of the language. So we can put any language into the parser, and when the parser accepts the language, then we can also flatten that stuff. So far, what's the future about traits in C#? So we still have to find satisfying solutions to certain problems. So, for example, the modifier keyword problem, I wasn't talking now about that, but that's a big issue still. We're still researching on that. And typing problems, so to find satisfying solutions for return types, argument types, and all that stuff. And of course, there are a lot of other things that could be implemented and used for traits in C#. And our goal is actually to make a clean implementation soon for rotor.net. So that is the goal for the next prototype. Okay, there are a lot of references available. So just go on our institute. You will find tons of papers about traits, more or less detailed. Some are extremely formal, some are not. Just have a look into that. There's an interesting paper coming up in May 2006, probably, hopefully. It's about flattening traits, so that's the proof of the flattening property, and it handles that in very detail and why that works, and all that proof and stuff. And there's also a little paper up from myself, so traits in C#. So I'm discussing all the things that I encountered during implementing traits in C#. So, for example, different kinds of syntaxes or declarations we could use, why we should use this one, why we shouldn't use another one, stuff like that, and all that you could do in C# and with traits. So, yeah. Okay, so that's the web page here. You will find everything about traits on that web page, not only for C#, but also for Smalltalk, for Roll, for Perl, and all the other approaches for traits in languages. Okay. Any questions? Yes?
Do you allow traits to be used as types? So you can actually refer to a trait in the source code as if it was a class name or an interface name.
Interfacing traits?
So if you had a trait, T-color and T-sequenceable, could you use that as a first-class type, basically like an interface?
I'm not sure. So we would like to have traits just as a container to behavior, just a primitive unit. So we don't want to introduce any kind of state and stuff like that. But there's some research about stating, encapsulating and typing traits for that. Yeah, there's some research going on. That's yeah.
Using the interface support that the CLR supports or provides. Interfaces into CLR actually allow you to have code in them. not in C# directly, but in CLI, which means that you could actually get most of the functionality you're talking about inside an interface, which would allow you to immediately treat them as distinct types.
Yeah, we're not that far, so we're far away from putting stuff into Rotor or .NET, so we just try to make the first step towards C#, but yeah.
Oh, wait, there's a question.
The question that you must be getting, but what's the connection between traits and aspects? Or is there any?
Well, the only aspect is that we just put a certain kind of behavior into a unit and share that, yeah, you could say aspect for many classes, but that I wouldn't say that there's a similarity between traits and aspects.
So you don't really see a relation?
Yeah, not much.
Okay.
No. Just the concept that you put a certain set of behavior into a unit that you share among other classes.
Okay, thank you.
Okay.